Hey guys, so welcome to today's question. It is which term of the sequence 5x, 20x, and 80x is equal to 20,480x? Okay, you know the story, always write out your sequence before we start. Now again, this is just the way I like to follow how I handle this, alright? Every person to their own. This is just my routine, if you'd like to say. Okay, and let's go ahead and indicate what terms are what. So 5x is term 1, 20x is term 2, and 80x is term 3. Okay, so we'll start off with testing for arithmetic sequence first, which remember is just addition or subtraction to the next term. So from 5x to 20x, we will need a plus 15x. And from 20x to 80x, we will need a plus 60x. All right, our first differences, which are these guys here, are not the same. So that means that we are definitely not doing an arithmetic sequence. Awesome, okay. So that means we're doing a geometric sequence. Even better, okay. Now what we're going to do is we're going to do our ratio test to see which one it is. So we'll just start off. We can start off, let's start off at the top one for a change. I'll start off with T3. T3 divided by T2, which is equal to 20x divided by 80x. Silly banana, got that the wrong around. Do apologize. That's 80x divided by 20x. Okay, the x's cancel each other out. The zeros will sum down, and 20 goes into 8 4 times. So let's check the ratio. Here is saying, it's not saying R, it's saying 4, my word. I am on such a roll today. Okay, now let's do the second test. So we're going to check term 2 and term 1. Alright, so term 2's value is 20x, and that's going to be divided by term 1's value, which is 5x. X is cancelled, 5 goes into 24 times. Oh yeah, cool. So our ratio has been confirmed that it is 4. Now let's look at what our standard form of our geometric sequence would be, which is Tn is equal to Arn to the power of Arn to the, what am I saying? Tn is equal to Ar to the power of n minus 1. Goodness me, tongue twisted today, I do apologize. Alright, so let's talk about what is A equal. A is always the value of the first term, which is 5x. What is R equal? R is a ratio, and we've already calculated that to be 4. So let's go ahead and plug in our substitution so we can see what our general nth term will look like, okay? Awesome. So we said that A has the value of 5x multiplied by R, which is the value of 4. So 5x multiplied by 4, and that will be to the power of n minus 1. Awesome. Okay, so let's go ahead and test this guy, right? Because this is technically what we've worked it out, but let's prove that it's right, okay? I feel like being a little bit spontaneous today. So instead of working with term 2, let's go ahead and work with term 3. All right, so here we go. Where I have t, I'm going to put term 3. Note that my 3 is in the place of n, and for the rest of the general nth term I will put a 3 for every n I bump into. Okay, so if t3 is equal to 5x multiplied by 4, and bam, we've jumped into another n, so I'm going to plug in a 3 and then minus 1. Okay, obviously at this stage you can just quickly chuck this wicked equation into our calculators and get a final answer. I just want to go through each step so you guys can see exactly how this, what happens as we're going slowly, all right? And then you'll know the process, which is always very cool. Okay, so let's check it out. What I want to do here is obviously simplify our exponents first. So we've got 5x multiplied by 4, and 3 minus 1 is 2. Awesome. Then we have 5x multiplied. What is 4 to the power 2? It is 16. Okay. So there we go. Now let's check it out. We've got 5 multiplied by 16. 5 times by 10 is 50. And 5 times 6 is 30. And 15 30 is 80. There we go. 80x. What is the value of term 3? Oh, it is 80x. That means we have just proven that our general nth term is correct. Wicked. Let's move this guy out of the way. Sneak it up a smidgen more. There we go. Okay, so now because we've done that and we've proven that our general nth term is right, we can go ahead and try and conquer the actual challenge at hand, which again is which term of the sequence 5x, 20x, and 80x is equal to 20,480x. Okay, Let's put our general nth term down first. Okay, so equals 5x, open bracket, 4, close bracket to the power n minus 1. Now, usually on the left-hand side in our previous videos, I had said t and then whatever number term they're looking for. Now, this time, they haven't given us a number term. They've actually given us a value. And using that value, we're going to find out what term it is, like what position it is, which is pretty cool. So instead of saying tn something blah, 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 we're going to put in the value. So that's 20,480x. Brilliant. Okay. Now that we've got our equation happening, let's go ahead and conquer good old-fashioned algebra, okay? Let's separate the 5x from the 4. Notice that they're being multiplied, so in order to separate them, I will divide, okay? And I'm going to divide by the number that I want to get rid of. And in order to keep balance in our equation, I shall divide it on the other side too, okay? So this x cancels out that x, and we shall see how many times 5 goes into 20,480. And it goes in 4,096. Wicked. All right, so we have 4,096. That is equal to 4 to the power of n minus 1. Notice I've thrown all the brackets away because there's nothing else being influenced. We don't really need to have those brackets there, and let's face it, without them there, it actually looks a little bit neater. Okay, so now we have 4,096 as our left-hand side. Note that our n, or our unknown, is in exponent. So what we want to do is to get our base numbers the same, all right? So I want to turn 4,096 into a number that would be 4 to the power of something. Okay, now I'm not too sure if you guys are familiar with prime factor ladders. Hopefully you are. If not, just watch what's happening. Okay, so easy peasy. I'm just going to take the 4,096. We're just going to create a ladder, really. Okay, and we're going to say 4,096 divided by 4, and that becomes 1,024. Now we're going to divide that by 4, and that's going to turn into 256. Dividing again by 4, and the reason we keep on dividing by 4 is because we want our base number to be 4, okay? So now 256 divided by 4 is going to give us 64. Then 64 divided by 4 is 16. And 16 divided by 4 is 4. And 4 divided by 4 is 1. As soon as you hit 1, you know you've gotten to the end and it is correct, all right? Notice we divided by 4 only. Okay, so we can make our base numbers the same. Now we just got to count how many we have. 1, 2, 3, 4, 5, and 6. Okay, so we can say that 4 to the power of 6 is equal to 4n minus 1. And we know that 4 to the power of 6 is equal to 4,096. We've just worked it out, okay? Now, we can see that our base numbers are the same. I'm going to highlight them so you guys know exactly what I'm talking about, the base numbers. When they're exactly the same, they can fall away, and then we're just working with exponents. So the way our equation is now going to look is going to be 6 is equal to n minus 1. Doesn't that look so much better? Finally, we got that variable out of the exponent. Exponent variables always seem a little bit wobbly, right? Well, now it looks a lot better. Okay, so we're going to take that minus 1, I'm going to chuck it over the equal sign, and the minute that happens, the negative turns into a positive, so we have 6 plus 1 is equal to n, and we can then say n is equal to 7. Alright, finally finishing it off. If you really want to look all fancy, we say therefore T7 is equal to 20,480x. Awesome, guys. Nice round. I hope you had fun. Check you in the next video.